This is my Miller Diversion 180. It is 6 years old, I've blown it up 4 times, it's the most boring machine in the world to look at and use, and is generally regarded as the most expensive machine on the market for entry-level TIG with the least amount of features. So what could I possibly do to make this thing any better? First and foremost, we need to get this case off of here, so it's nothing more than just grabbing a hold of the drill here with a T27 Torx bit and ripping all these screws out one by one to get this case off of here. As soon as I get it off of there, you can see what a mess the inside of this thing is, and it's probably been a very, very long time since this has been apart, but quick blast with the air gun. You should probably be wearing a dust mask or some sort of respirator because you really don't know what's in here. If you get in kind of close and look at this, just look at all that dust in there. You don't really want to be breathing all that stuff up. So I'm going to go a little bit extra further on this one. I'm going to wipe it all down with a rag and just kind of clean it up because I want it nice and presentable. Now after this, I'm just going to pack it up real quick and I'm going to take it off to get a checkup. I took it down to the welding repair store. They looked at me crooked as can be because I said there was absolutely nothing wrong with the machine and all I really wanted was just a quick little checkup on it. So 75 bucks later, I'm pretty sure they didn't do a single thing except for plug it in, but I got it back and there's more to be said before we get going here. Make no mistake and understand 100% in full that if you are doing any of these modifications to your machine and your machine is under warranty and something happens, you're probably not going to have a warranty when it's done. So make sure to use your own discretion on this when performing any of these modifications. But this welding machine in particular is 6 years old, out of warranty, and I've got to modify it. So let's continue on. Positively, one of the biggest downsides to the Miller Diversion 180 is that the leads are attached permanently. You actually can't take them off of there. So storing the machine means you got to wrap the leads all around it and all kinds of other craziness. And it's, you know, they get tangled up and it's kind of a pain in the butt. So I most certainly want to correct that one. I want to get these permanent leads out of here, and I'd like to put in some removable ones, which makes it nice and clean. I'm also going to strip down the rest of the machine so that way it's a little bit more easier to work. I'm going to take this big pile of nonsense over here and just toss it aside. Now there's a couple of companies that actually make a retrofit kit to use removable leads with these DINS connectors for the Diversion 180 for about $140, which is kind of ridiculous. So I just went straight to Everlast actually, and I picked up a couple of these connectors along with the 9mm quick connect for the torches that I use because I have mostly Everlast torches. So these are nothing more than just DINS connectors, and we have to modify it in order to get them to fit into the actual machine itself. So the best thing to do is grab a hold of a hole saw. This is an 1.25" hole saw. It closely matches the outside diameter of that DINS connector itself, and we're gonna cut it out basically. But you notice that there's nowhere to really put that pilot hole to make it line up and make a nice clean cut hole. So obviously with the other kits they have an arbor adapter, but I'm just going to take a board, some scrap wood, and I'm going to clamp it inside the machine. It's well, it actually doesn't get a whole lot easier than this. So as soon as the board is lined up, we can take the center of our hole saw or our pilot drill or our pilot bit, whatever way you want to call it. Just stick it in here, drill through nice and easy, and as soon as it breaks its way through, we have the center of our hole in the right spot, and the rest of it can be cut out in pretty much whatever place we want it. We can go right into the center of the hole, we can go low on that one like I did, or on the bottom here like I'm doing. I'm going high on the hole so that way it doesn't cut too low on the actual machine. Pretty simple, easy day. Now if you look carefully, we have a little bit of a tang that comes onto this DINS connector. That's so it actually stays in place while you rotate the torches to lock them in. Now obviously it's not going to fit in here with that small of a hole since it only matches the diameter of the actual outside of that boss on there. So to make this tang cut out, I'm just going to go ahead and grab a hold of a file, and we're just going to knock a little notch out here until it actually fits. Not rocket science, just simple file away until it fits itself inside of there. Give it a test fit. Now it doesn't move, it's ready to be installed. Before I can actually do that, I'm going to clean up the edges with a little deburr tool, knock down the edge of this. Very simple little tool. You can use a file, you can use whatever you got, no big deal. The Diversion 180 comes from the factory in the electronegative orientation, so that means that we're going to have to put our red connector on the ground lead or the work clamp, and we're going to have to put our black connector up top on the actual torch for the torch lead, making it still stay electronegative. Doesn't mean we can't switch it, but to avoid confusion, it will stay in electronegative. One problem you may encounter is alignment. Now, this is something you need to pay attention to, because if your hole does not line up perfect, you're going to have to bend your negative lead just a little bit. Now remember, this is solid wire, so bend it gently, go easy on it, and as soon as you have it lined up, tighten it down and make sure it's not contacting any part of the chassis at all. You gotta make sure it's nice, clean, snug fit. Take your time, do it right. Finally, I'm gonna add the 9mm quick connector for the argon line for each one of the torches. Just gonna throw a little Teflon tape around these threads, throw it in where the old hand controls used to be for the Diversion 180, give it a snug fit, and this portion of the modification is knocked off the list. I definitely don't understand gaming in the ways that anybody else does, but I totally respect the builds that they do for their cases. So we're gonna take this relay board and we're gonna use it to light up a whole bunch of LEDs inside this machine, so that way it looks cool, because well, quite literally, this is the most boring looking machine in the entire world. So in order to do this, I went over to eBay, grabbed myself an Arduino style board, basically a relay controller board. I don't have the part number, I didn't save it, I don't know who sold it, I don't know who made it, so just get on eBay and look up Arduino relay board and you'll find all kinds of stuff. But this one has to be 24 volts, and we'll get into all of that. Now, in order to not make the board short out to the chassis of the welder, we're going to have to elevate it using these little standoffs, and these things are very tiny, and I am zoomed in very close, and quite literally they're a pain in the butt to stick on there. But either way, as soon as I got it marked out, drilled up, and mounted, we can get onto the actual wiring to make all these LEDs light up. But first we got to actually install them. So I'm going to grab a hold of these LED strips. The strips that I bought are 24 volt LED strips, and I'm going to use a whole bunch of these things because I had this really wicked design inside of my brain, and I got to make it all happen with a lot of LEDs. In the event that one of these LEDs goes out, I did go ahead and get these reusable connectors for LED strips. You get about 10 of them for like $1 shipped. So made sure to get a whole bunch of those. These are self-adhering, and they should stick just fine. I'm actually going to epoxy the clips themselves to the chassis of the welder, and again, this is just so I can replace the LED strips later. But as soon as I get them stuck on, give them a quick test, make sure that they're actually working good, and we're just going to stick all the other ones on there. Now, I don't want them to be like plainly visible, I just like the light to be visible, so I'm going to kind of hide them as many places as possible, including the top and around the edges and the bottom of the machine. Now, the source that we're going to use to tap into for the power on this one, I'll get a little bit further in detail, but it's going to come from the gas solenoid, because the gas solenoid is 24 volt DC power. Now, the constant source for the power is there. I mean, it's always 24 volts. Like I said, I'll get into all of this, but we're basically going to get our two lines connected for the power of the relay board and the LEDs into the actual solenoid itself, and I'll show you how the rest of it works as soon as I get all this connected. I'm also going to clean up the wiring on this one, kind of make it look a little bit nicer, so good uniformity, good routing, make it pretty. Now, while I get to wiring this relay board up here, we'll just kind of explain exactly how I did everything. Now, if you're not familiar with schematics or wiring or anything like that, and it looks really confusing, I'll just tell you simply, look at it in its simplistic form. Now, you know exactly what's going on here, and where it connects is exactly how it works. Okay, so just look at it one line at a time. But if you're not familiar with it, you have any questions, you're a little confused on how I did it, you can drop a comment down there. But if you're not familiar with it, it's going to be very hard to respond in a manner that you can understand it, but I'll do my best, okay? No guarantees. When you switch the machine on, when you turn it on basically to use it, or the power to the machine is actually basically turned on, we have a positive 24 volt DC constant source that is always on, and we're going to tap into the solenoid valve, which also carries that same 24 volt DC positive source. Okay. Now, with the relay, you have a normally closed and a normally open side. Closed meaning there is a path, so we have a path to ground. So if we hook the blue lead up to our positive 24 volt DC source, and then we stick the normally closed side to the ground, as soon as we turn the machine on, the blue LEDs will light. They will actually turn on. Now, when we want to start welding, that's when the solenoid valve is going to close. That means that the source to ground the solenoid valve is switched on by the machine. So if we tap in our relay board ground to the actual solenoid valve negative side, then it will switch the relay board on, thus switching all the relays from the normally closed to the normally open side, which then becomes the closed source and the path for the ground, or the path for the red LEDs to light up. Now, again, that probably sounds very confusing, and I'll do my best to explain if you need further explanation, but basically run back through this, look at it again, double check, all the rest of that good stuff. And again, if you need some further explanation or a little bit different way or approach to kind of understand it there, just, give me a shout there in the comments, I'll let you know. So now that it's all wired up, let's actually turn this thing on and see what it looks like. Wow, those blue LEDs are freaking sick. Look at that. I'm going to step on the pedal here just to make sure that the red side actually goes, and it certainly does. And as soon as it goes through its cycle of post flow, since we're wired in the solenoid, it should switch back to blue. Boom, just like that. Now these LEDs look positively sick inside of that thing, but guess what? They're completely useless if we can't see into the machine. So in order to see inside the machine, we're going to have to cut some holes in the side of the case. But the problem with that is if we have all these big giant holes inside of the case, then we're not going to have any airflow to keep the machine cool, thus probably making it blow up. So what I'm going to do is measure out and cut a sheet of acrylic on the CNC machine. Now in order to come up with this really cool idea to keep these decals in the same place and all the rest of that good stuff, I'm going to have to do some really clever measuring. And it's going to have to incorporate some airflow and all the rest of that good stuff. Now to save a little time on this video, because it's already pretty long, I'm just going to do this pretty crazy looking montage. And if you want to rewind it 3 times and watch all each section again, go for it. But here we go. Oh man, you can probably only imagine as soon as I got this case cleaned off how quickly I wanted to stick it onto the chassis and see what it looked like. And of course I wasted no time whatsoever doing that. As soon as I slipped it on here, check this out. That looks insane. All the guts are cleaned up, you can see inside, it lights up. That is epic. But I've got to get these windows on here so we can actually use it, and the outside of this case looks terrible. It's ugly. So let me get onto this acrylic real quick. We pull these sheets off of the CNC. They do have some messy edges. That was the first time I have ever cut acrylic on the CNC machine, so my feeds and speeds were really an educated guess. Now I'm going to take the edge reamer here and just kind of deburr these, scrape it off nice and clean. And there is one thing that I need to do to ensure that the inside that I engraved around the logo where the decal is going to sit is going to light up more than the edges, because the edges are not going to be seen, but that section of the decal will. What I'm going to do is attack these edges with fire. We are doing what we call flame polishing to clear off those edges. It makes it from a rough surface cut, and when you burn it back together, it basically just melts it so it becomes more translucent and not opaque. So as soon as I get that done, I'm going to line the new decal up here, make sure it is perfectly set in that engraved area, so that way when the LED hits that engraved area, which is left with the machine finished and opaque, it will light up in the color that the machine is lit up. So some very careful measuring, stick it on here, make sure there's no air bubbles, and I'm going to go ahead and grab a hold of it and throw it up inside the machine because yet again, I cannot wait to see what it looks like. Man, I am absolutely loving the crap out of this. This looks insane. I struggled just a little bit on deciding what I wanted to do for the outside finish on this case. I was thinking anything from really dope paint job, maybe some like racing stripes because I'm in the automotive performance fabrication world, just about everything. But after going to the YouTube community tab, I put up there, I said, hey, what should I do with this one? And one of the things that was suggested was carbon fiber wrap. And since I just happened to have some laying around, just sitting on the shelf collecting dust, I said, well, I'll give it a go. Let's make it happen. Carbon fiber would look totally sick on this one. Now, if I had the time to lay it out entirely by hand and use real carbon fiber, I totally would have, but unfortunately I didn't. Now, I'm not much of a rapper, but I can certainly hold my own. Well, I mean, you know, rap like vinyl. Whatever. In order to get this to look nice and sweet and clean and laid down and almost professional like I knew what I was doing, I'm going to make sure I take my time. I'm going to use the heat gun, of course make sure the squeegee runs, and make sure that all of the air bubbles come out of this like it's supposed to. Fine trimming with the razor blade, nice and sharp, make sure it's all good to go, and we'll cut the windows out, get all the rest of this thing set up, and this will be the final reveal on our case. We are on the home stretch right now, which means all I have to do is get this acrylic cleaned up and get it ready to be epoxied onto the case of the machine, and I am excited. So excited that I absolutely cannot wait to see exactly what this looks like, but I still must take my time and make sure that I do a good job on here, like mixing up this epoxy here. Now this is nothing more than some JB Weld epoxy that works exceptionally well on acrylic to metallic surfaces or to painted surfaces. Has about a 5-minute set time on it, so you gotta be relatively quick. Now, a little dab will do you on the edges on this thing because I did cut it very, very close to the size of the window, and I don't want the epoxy oozing out of the side of it because I can't necessarily wipe it off without destroying the acrylic, so I must make sure it's applied well enough, but not too much. In order to make this thing stick over the course of the next 5 minutes, I'm going to stick it down with some weights, and then while that's drying and setting up, I decided I'm going to attack these handles and I'm going to change the color of them as well as the hardware for the outside of the case. I'd like it to contrast that carbon fiber. Now there were some fantastic suggestions offered up by viewers on the YouTube community tab when I posted up the dilemma, but I decided I was going to go with a full-on color change to super special Miller blue paint, also known as Ford blue, which is super close. It's actually really close. So we're going to get all these sprayed up here. Good old-fashioned, just stick the hardware into a piece of cardboard or a paper plate. We'll hang up the handles on a piece of welding rod that I have laying around. Make sure that they're nice and clean, shoot them well, let them hang up to dry for the manufacturer specifications, and we'll get to checking on our windows, which should be fully cured by now. And really, I am excited. Here we go. Final assembly. I'm going to blast everything off with a good, clean, fresh blast of air. Make sure that there's no dust, lint, or anything on the inside of these windows, which means I'm going to hit it with the air first, followed by a good, quick cleaning with the microfiber just to make sure that there are no pieces left on this acrylic. I want to make sure that it's nice and clear. And this is the last time this case will be off of the chassis. I am going to shut up now so we can watch this thing go back together. there's a couple of things that you should do before we get out of here. One, make sure that you're subscribed to the Fabrication Series channel, and two, make sure you click that bell, because on the YouTube community tab, we have all the insider stuff, exclusive content, and everything else that you're going to want to see before the video actually comes out. So make sure that you do that. Second, if you need to get a hold of me, you can always email me on the fabricationseries.com website. Hit me up on Instagram at the.fabricator or facebook.com/thefabricatorseries. Make sure you check the description below. All that info is going to be in there. Now, I want to thank you guys for watching. As always, don't forget to subscribe to the Fabrication Series YouTube channel. And if you do a really custom build like this one, make sure you tag me, send me pics, and all the rest of that good stuff, because I definitely want to check that out. We'll see you guys on the next episode.